somewhere beneath your feet, deeper than the deepest ocean trench, deeper than any drill has ever reached, an ocean of liquid metal is churning in the dark. It has been moving for billions of years, and as long as it keeps moving, you are wrapped in an invisible shield that surrounds the entire planet. But here is the strange part. Every magnetic field we know of should fade. Switch off the current that feeds it, and the field dies almost at once. So why hasn't Earth's field died? Why, after 4.5 billion years, is it still here, still strong, still guarding us? The answer is not that Earth was magnetized once and simply remembered how. The truth is far stranger. Earth's magnetic field is being destroyed and rebuilt constantly, right now, in a process that should not be able to feed itself. And yet, somehow, it does. Before we go any deeper, if you enjoy these journeys into how our own world secretly works, a quick like or subscribe really helps the channel grow. It's a small thing for you, but it makes a huge difference for me. Also, before we begin, we're now live on Spotify. The link's in the description if you'd like to listen to us wherever you are. Now, let's begin. Let's start with a fact that sounds almost too simple to be interesting, and then watch it turn into one of the deepest puzzles in all of planetary science. Every magnetic field you have ever encountered has a source, and that source has to be maintained. Take the magnet stuck to your refrigerator. Its magnetism comes from the way countless tiny atomic magnets inside the metal are locked into alignment, all pointing roughly the same way. That alignment was frozen in when the magnet was made, and the material is stubborn enough to hold it. But even that kind of magnet is not truly permanent. Heat it up enough, drop it enough times, leave it for long enough, and the alignment slowly drifts apart. The field fades. Now consider a different kind of magnet, the kind that matters for our story. If you take a loop of wire and push an electric current through it, that moving current wraps a magnetic field around itself. You have built an electromagnet. It is genuinely magnetic, strong enough to pick up nails, strong enough to run a motor. But here is the thing that makes it different from your fridge magnet. The moment you switch off the current, the field collapses. Not slowly, almost instantly. There is nothing holding it up anymore, so it simply falls away into nothing. The magnetism was never stored in the metal. It was being actively produced, moment, by charges in motion. Stop the motion, and you stop the field. Hold on to that image, because it is the key to everything. A magnetic field that depends on flowing currents is a field that has to keep being paid for. It is like the beam of a flashlight. The light looks like a solid, steady thing hanging in the air, but it is not a thing at all. It is a continuous stream, replaced billions of times over, even as you watch it. Cut the power, and the beam does not slowly dim over hours. It vanishes the instant the battery dies. So now, let's turn to Earth, and to the enormous magnetic field that surrounds our entire planet. This field is real, and it is powerful. It reaches out thousands of kilometers into space. It is what makes a compass needle swing to point north. It has been guiding migrating birds and turtles, and even some bacteria, for as long as those creatures have existed. And crucially, this is not the fridge magnet kind of field. This is the electromagnet kind. It is generated by electric currents, by charges in motion. Which means, by everything we just said, it should behave like the flashlight beam. It should require constant power. Switch off the currents, and the whole thing should collapse. And here is where the paradox bites. If you took Earth's magnetic field as it exists right now, and you somehow shut off the machinery that generates it, and then you simply left the planet alone, the field would not last forever. it would fade. Physicists can estimate how long this decay would take, and the answer, while long by human standards, is astonishingly short by the standards of Earth's history. Left entirely to itself, with no source keeping it going, Earth's magnetic field would drain away in something on the order of tens of thousands of years, maybe a bit longer, but nowhere near the age of the planet. On a geological clock, that is the blink of an eye. And yet, our planet is about 4.5 billion years old, and when scientists read the magnetic record locked inside ancient rocks, which we will get to, they find that Earth has possessed a substantial global magnetic field for the overwhelming majority of that immense span. Billions of years. Not tens of thousands, billions. Do you feel the weight of that contradiction? A field that, left alone, would fade in a geological instant, has instead persisted across nearly the entire life of the planet. That is like walking into a room, finding a candle burning, and being told that same candle has been burning continuously since before there were dinosaurs, since before there was multicellular life, since almost the very beginning of the world. Your first thought would be, that is impossible. A candle burns out. Something must be relighting it. Something must be feeding it. That instinct is exactly right. Earth's magnetic field is not a relic. It is not an ancient imprint that got stamped into the planet once and has simply lingered ever since. If that were the story, the field would be long gone. Instead, the field is being actively generated, continuously, right now, by a process happening deep inside the Earth. It is being rebuilt as fast as it decays. The candle is being relit, over and over, forever, by a flame we cannot see. So the real question, the one this whole journey is about, is not simply, does Earth have a magnetic field? Of course it does. The real question is far more demanding. What is down there, keeping it alive? What machine has been running for 4.5 billion years without stopping, converting some hidden supply of energy into the invisible shield that wraps our world? And how does a magnetic field manage to sustain itself when everything we know about magnetism says it should collapse the moment its source flickers? To answer that, we have to go down, way down. Let's take an imaginary journey toward the center of the Earth. You start at the surface, on the crust, the thin skin of rock we live on. The crust feels enormous to us. Mountains, canyons, ocean floors. But in the scheme of the whole planet, the crust is laughably thin, thinner in proportion than the skin on an apple. Beneath it lies the mantle, a vast, deep layer of hot rock. The mantle is mostly solid, though over enormous timescales it can slowly flow and churn like extraordinarily stiff toffee. This is where most of Earth's internal volume lives. But for our purposes, the mantle is not where the magic happens. It matters, and we will come back to it, but it is not the generator. Keep going. Pass through thousands of kilometers of mantle, the temperature and pressure climbing with every step, until you reach a boundary. This boundary sits roughly halfway to the center, and it is one of the most important places in the entire planet, even though no human will ever see it. On one side, above, is the solid rock of the deep mantle. On the other side, below, everything changes. You have arrived at the edge of Earth's core. And the core is not made of rock, it is made of metal. Overwhelmingly iron, mixed with some nickel and a scattering of lighter elements. This is the dense heart of our world, the heavy material that sank to the center long ago when the young Earth was molten. And the core has two parts, which we absolutely must keep separate in our minds, because confusing them is the single most common mistake people make about how the magnetic field works. The core has an outer part and an inner part. The outer core is a colossal shell of liquid metal, a genuine ocean of molten iron alloy, thousands of kilometers thick, sloshing and churning around the very center of the planet. And then, right at the middle, sits the inner core, which is solid. A ball of iron, roughly the size of a small moon or a dwarf planet like Pluto, so squeezed by the crushing pressure at the center of the Earth that despite being ferociously hot, it cannot melt. It stays solid, a metal sphere at the heart of a metal sea. Now here is the trap. Many people, when they first hear that Earth has a solid iron ball at its center and also has a magnetic field, put two and two together and conclude that the inner core must be a giant bar magnet. A cosmic compass needle buried at the middle of the world, its north end pointing one way, its south end the other, magnetizing the whole planet from within. It is a tidy picture. It is also wrong. It cannot work that way, and the reason is beautiful in its simplicity. Iron loses its permanent magnetism when it gets hot. There is a specific temperature, and above it, the neat atomic alignment that makes a permanent magnet simply falls apart. The heat jostles the atomic magnets too violently for them to stay in formation. That temperature is high, but it is far, far cooler than the inside of Earth's core. The inner core is thousands of degrees hot, hot enough that iron there could never hold a permanent magnetic alignment. So the solid inner core, whatever else it does, absolutely cannot be a permanent magnet. It is simply too hot to be one. The bar magnet picture is dead on arrival. So the inner core is not the source. Then what is? The answer is the outer core, the liquid one, the ocean of molten iron. That is where Earth's magnetic field is truly born. And the reason a moving liquid metal can do something a solid hot ball cannot comes down to two pieces of physics that, once you see them, unlock the entire mystery. The first piece is this. A liquid metal is an outstanding conductor of electricity. We tend to think of conductors as solid wires, but a liquid can conduct just as well, sometimes better. And the outer core is not just any liquid, it is molten iron, and iron carries electric current with ease. So picture that entire vast ocean of the outer core as one continuous, planet-spanning body of electrically conducting fluid. It is essentially a liquid wire wrapped around the center of the Earth, thousands of kilometers deep, but a wire that can slosh, swirl, rise, sink, and flow in 3 dimensions. The second piece is the deep connection between motion, electricity, and magnetism, and it works as a loop with 3 links. The first link. When you move an electrical conductor through a magnetic field, you push on the charged particles inside that conductor, and that push can drive an electric current. This is not exotic physics. It is exactly how every electric generator on Earth works, from the alternator in your car to the giant turbines in a power station. Spin a coil of wire near a magnet, and current flows in the wire, produced by nothing more than the motion. The technical name is electromagnetic induction, but the plain language version is simply this. Move a conductor through a magnetic field and you generate electricity. Motion becomes current. The second link we have already met. An electric current generates a magnetic field. Any current, anywhere, wraps a magnetic field around itself. This is unbreakable. Currents and magnetic fields are 2 sides of the same coin, so current becomes field. And now, watch what happens when you put those 2 links back to back. Motion through a magnetic field creates current. Current creates magnetic field, which means, in principle, the moving conducting fluid could be creating the very magnetic field it is moving through. The output of the second link feeds the input of the first. The magnetic field pushes on the moving fluid to help drive currents, and those currents produce magnetic field, round and round. That closed loop is the third link, and it is the whole secret. It is called a self-sustaining dynamo. The word dynamo just means a generator, a machine that turns motion into electricity and magnetism. What makes this one self-sustaining is that it does not need an outside magnet to keep it going. Once it is running, the field it produces is the field it needs. The system feeds itself. Motion generates field, field helps generate current, current regenerates field, and the field then keeps organizing the motion. It is a snake swallowing its own tail, except that instead of disappearing, it keeps itself alive. Let me make sure that lands, because it is genuinely one of the most elegant ideas in physics, and it is very easy to feel like it must be a trick. It sounds almost like something for nothing, a field that makes the current that makes the field. Isn't that a perpetual motion machine? Isn't that impossible? And this is the crucial clarification, the one that keeps the whole idea honest. No, it is not something for nothing. The dynamo does not create energy out of thin air. It cannot, because nothing can. What the dynamo actually does is far more modest and far more believable. It is a converter. It takes energy that is already there, a supply of energy stored inside the Earth, in a completely non-magnetic form, and it converts a portion of that energy into the motion of the fluid, and then converts a portion of that motion into electric currents and magnetic fields. The magnetic field is not free, it is paid for. Every bit of magnetic energy in that self-sustaining loop was bought with energy drawn from somewhere else inside the planet. Think of it like a hydroelectric dam. The spinning turbines and the electricity they produce can feel like they appear from nowhere, but of course they do not. They are powered by water falling from a height, by the energy the water gained when the sun lifted it into the sky as rain. The turbine is just a converter, turning the energy of falling water into the energy of electric current. The dynamo in Earth's core is the same idea. The churning of the liquid metal is the falling water. The magnetic field is the electricity. And some source of energy deep in the Earth, is doing the work of lifting the water, of keeping the fluid churning so the whole loop can run. Which raises the obvious next question, and it is the question we are about to spend a good while answering. If the dynamo is a converter, what is it converting? What is the falling water? What is the hidden supply of energy that has kept that ocean of molten iron in restless motion for 4.5 billion years, so that the magnetic loop never runs down? But before we chase that energy, let's sit for one more moment with just how strange and specific this arrangement is, because it tells us why so few worlds have what Earth has. Notice everything that had to line up. You need a large body of material that is metallic so that it conducts electricity well. Rock will not do. You need that conducting material to be liquid so it can actually flow and swirl, because a solid conductor sitting still generates nothing. A frozen metal core is magnetically dead. You need that liquid to be in vigorous motion, not just sitting there, because without motion there is no induction, no current, no field. And you need a steady, long-lasting supply of energy to keep that motion going for billions of years, because the instant the churning stops, the whole self-feeding loop unravels and the field decays away in that geological blink we talked about at the start. Miss any one of those ingredients and the dynamo fails. And that is exactly why the magnetic field is such a fragile, precious thing when you look across the planets. It is not enough to be big. It is not enough to have iron. You need the iron to be liquid and moving and powered. When we later look at Mars, at Mercury, at our own moon, we will find worlds that had some of these ingredients but lost the others and paid the price with dead or dying fields. Earth kept all of them, so far. There is one more idea to plant here before we descend into the engine room, and it is the idea that separates a real understanding of the dynamo from a cartoon of it. When I described the loop, motion makes current, current makes field, field helps drive motion, I made it sound like a single, tidy circle, one clean cycle turning smoothly like a wheel. And that mental picture is useful for grasping the basic principle. But the truth inside the outer core is nothing like a single, tidy wheel. The real dynamo is turbulent. It is three-dimensional. It is churning in countless swirls and streams and eddies at once, at many different scales, all tangled together, all changing from moment to moment. There is not one loop. There are innumerable interlocking motions, and the magnetic field threaded through them is equally complex, being stretched here, twisted there, folded somewhere else, all at the same time. And most importantly, the magnetic field is not just a passenger being carried along by the flow. The field pushes back. A strong magnetic field exerts forces on the moving, conducting fluid, nudging it, resisting it, reshaping the very motions that are generating the field in the first place. That two-way relationship, where the flow shapes the field and the field shapes the flow, is what makes this a coupled system, rather than a simple one-way chain of cause and effect. It is a conversation between the moving metal and the magnetism, each one constantly influencing the other. And out of that endless, turbulent conversation, somehow, a large-scale, remarkably organized global field emerges, the one your compass feels, the one that reaches into space. How a churning, chaotic, three-dimensional mess of liquid metal manages to produce something as orderly as a planet-wide field with a recognizable north and south is one of the most fascinating parts of the whole story, and it is a puzzle we will unravel step by step. So let's take stock of where we now stand, because we have already overturned a lot of intuition. We started with a paradox. Magnetic fields that depend on currents should collapse the moment those currents stop, and Earth's field, left alone, would indeed fade in a geological instant. Yet it has endured for billions of years. We resolved the paradox by realizing the field is not a leftover relic at all. It is being continuously regenerated, rebuilt as fast as it decays, by a process running deep inside the planet right now. We located that process. It happens not in the crust, not in the mantle, not even in the solid inner core, but in the liquid outer core, the vast ocean of molten iron alloy surrounding the center of the Earth. We cleared away the tempting but false idea that the solid inner core is a giant permanent magnet, and we saw why it cannot be. It is simply too hot to hold any permanent magnetism. Iron that hot forgets how to be a magnet. We uncovered the engine's basic principle. Because the outer core is liquid metal, it conducts electricity superbly, and because it is in motion, it can generate electric currents through electromagnetic induction, the same principle behind every generator on Earth. Those currents produce a magnetic field, and that field, in turn, pushes on the moving conducting fluid and helps drive further currents, closing the loop into a self-sustaining dynamo that keeps its own field alive. We kept ourselves honest by insisting the dynamo creates nothing from nothing. It is a converter transforming some hidden internal energy supply into fluid motion and then into magnetism, exactly the way a dam converts falling water into electricity. And we glimpsed the real complexity beneath the clean cartoon. The genuine dynamo is turbulent, three-dimensional, time-dependent and coupled, a two-way conversation between flow and field rather than a single tidy wheel. But we have left a giant question hanging in the dark, and it is the question that determines whether this whole beautiful machine can actually run for the age of a planet. A dynamo needs power. It needs its falling water. It needs a source of energy vigorous enough and long-lived enough to keep an ocean of molten iron in restless motion, not for a moment, not for a million years, but for billions upon billions of years, without the churning ever fully stopping. Because the day the churning stops, the currents fade, and the field, obeying that very first rule we learned, drains away and dies. What could possibly supply that much energy, that steadily, for that long? Where is the falling water hidden inside the Earth? What keeps the metal moving? The answer turns out to involve heat leaking out of a slowly cooling planet, a frozen ball at the center that is quietly growing larger every year, and a subtle rain of light elements drifting upward through the liquid metal. It is an engine room stranger and more ingenious than you might expect, and it is where we are headed next. We arrived just now at a demand that the dynamo cannot escape. It needs power. It needs a steady, enormous, long-lasting supply of energy to keep an ocean of molten iron churning for billions of years. Because the moment that churning stops, the whole self-feeding loop unravels, and the magnetic field drains away and dies. So the entire survival of Earth's field comes down to a single question. Where is the energy hidden, and why hasn't it run out? Let's begin with the most fundamental source of all, one so simple it is easy to overlook. Earth is hot inside, and Earth is slowly cooling down. That is the whole starting point. Our planet was born hot. It formed by the violent gathering together of countless smaller bodies, each impact converting the energy of collision into heat, and it finished its assembly with a colossal reservoir of warmth stored in its deep interior. And it has been slowly, patiently letting that warmth escape ever since. This is worth pausing on, because it is genuinely strange when you first think about it. The center of the Earth is roughly as hot as the surface of the Sun, thousands of degrees. That heat has been down there for 4.5 billion years, and it is still there, still enormous, only gradually leaking away. The Earth is like an oven that was switched on at the beginning of the world, and then switched off, and has been very, very slowly returning to room temperature ever since. So slowly that after billions of years, it is still glowing hot at its heart. Now, here is the crucial link between a cooling planet and a spinning compass needle. Heat, on its own, does not just sit still. Heat flows, and it flows from hot places to cold places. The deep interior of the Earth is hot. The surface, facing the cold of space, is comparatively cool. So heat is constantly trying to travel outward, from the core, up through the mantle, and eventually out into space. The core is losing heat to the mantle above it, and that simple fact, heat escaping upward out of the core, turns out to be the beating heart of the entire dynamo. Why? Because of a process you have witnessed 1,000 times without thinking about it. Convection. Watch a pot of water heating on a stove. The burner warms the water at the bottom. That warmed water expands slightly, becomes a little less dense than the cooler water above it, and because it is lighter, it rises. It floats upward toward the surface. Meanwhile, cooler, denser water from the top sinks down to take its place, gets warmed by the burner, and rises in its turn. The result is a restless, rolling, circulating motion, hot fluid rising, cool fluid sinking, over and over. That is convection, and it is driven by nothing more than a temperature difference and gravity working together. The engine behind convection is called thermal buoyancy, and buoyancy is simply the tendency of lighter things to rise through heavier things. A cork rises through water because it is less dense than water. Hot fluid rises through cooler fluid for exactly the same reason. Heat it, it expands, it becomes less dense, and up it goes. Cool it, it contracts, it becomes denser, and down it sinks. As long as you keep heating the bottom and cooling the top, the circulation never stops. Now take that pot of water and replace it with something almost unimaginable. Replace it with the outer core, an ocean of molten iron alloy thousands of kilometers deep. It is being heated from below and from within, and it is losing heat from above into the base of the mantle. So the very same thing happens, just on a planetary scale and with liquid metal instead of water. The hotter, less dense metal deep in the core rises. The cooler, denser metal sinks, and the entire outer core rolls over in slow, vast, churning convection. And there it is. That is the motion the dynamo needs. Remember, the whole self-sustaining loop from before depends on the conducting fluid moving. A still ocean of metal generates nothing, but a convecting ocean of metal, rising and sinking and flowing, is exactly the moving conductor that electromagnetic induction requires. So the chain is now complete on this end. Earth is hot, Earth is cooling, heat escapes from the core. That heat loss drives thermal convection, hot metal rising, cool metal sinking. That convecting motion is what the dynamo converts into electric currents and magnetic field. The falling water we were looking for, the source that powers the whole thing, begins with a planet quietly shedding the heat it was born with. But thermal cooling is only the first of the engines down there, and on its own, many scientists suspect it might not be quite enough to keep the field as strong as it has been for as long as it has. There is a second engine, and it is subtler, cleverer, and in some ways more remarkable than the first. To find it, we have to return to that solid ball at the very center, the inner core, and pay attention to something it is quietly doing right now. The inner core is growing. Remember that the inner core is solid iron, while the outer core around it is liquid iron. That difference is not permanent or fixed. It is a frozen boundary that moves. As the whole planet slowly cools, the conditions at the very center gradually shift, so that more of the liquid iron at the base of the outer core can freeze onto the solid inner core. Bit by bit, layer by layer, liquid metal at the boundary solidifies and joins the growing solid ball. The inner core is, in the most literal sense, freezing, but from the inside out. It is a ball of ice growing at the center of the world, except the ice is solid iron and the water is molten metal. This is happening slowly, on a geological timescale, adding perhaps a fraction of a millimeter of new solid iron around the inner core each year. But over the vast spans of Earth's history, that slow freezing has enormous consequences, and it feeds the dynamo in not one, but two powerful ways. The first way is heat. This one is a little counterintuitive, so let's take it carefully. When a liquid freezes into a solid, it releases heat. That sounds backward, doesn't it? We tend to associate freezing with cold. But think about what freezing actually is. In a liquid, the atoms are jostling around, moving freely. To lock them into the rigid, orderly arrangement of a solid, they have to give up some of that energy of motion, and that energy is released as heat into the surroundings. This released warmth is called latent heat. It is the heat that was, in a sense, hidden inside the liquid state, and it comes pouring out at the moment of freezing. You have actually felt the reverse of this. When ice melts, it absorbs heat, which is why ice keeps a drink cold. It is soaking up warmth to make the transition from solid to liquid. Freezing does the opposite. It gives warmth back. So every year, as a thin new shell of liquid iron freezes onto the growing inner core, it releases latent heat right there at the boundary between the inner and outer core. That heat then has to travel outward, up through the liquid outer core, which means it adds to the convection, giving the churning ocean of metal an extra thermal push from below. So the freezing of the inner core is not just a passive side effect of cooling. It actively pumps additional heat into the outer core, precisely where it can help drive the flow. But the second way the growing inner core feeds the dynamo is even more elegant, and it introduces an entirely new kind of buoyancy, one that has nothing to do with temperature at all. Here is the key insight. The liquid outer core is not pure iron. It is iron mixed with some lighter elements, things like oxygen, sulfur, silicon, dissolved into the molten metal like salt dissolved in seawater. Now, when the iron at the boundary freezes onto the inner core, it does something selective. The solid iron does not want those lighter elements in its crystal structure, so as it freezes, it largely excludes them. It takes the iron and leaves the light elements behind, expelling them into the liquid just above the freezing boundary. It is exactly like what happens when seawater freezes into sea ice. The ice comes out surprisingly fresh, because the freezing process rejects most of the salt, leaving the water below saltier than before. So picture the base of the outer core, right at the surface of the growing inner core. Iron is freezing out and joining the solid ball, and it is leaving behind a residue of lighter elements in the liquid. That means the liquid right there, now enriched with light elements, has become less dense than the ordinary liquid metal above it. And what do less dense fluids do? They rise. They float upward through the heavier liquid above them, just as a cork rises through water, just as warm water rises in the pot. This is a second source of buoyancy, and it is called compositional buoyancy, because it comes not from heat, but from a difference in chemical composition, in what the fluid is made of. Plumes of light element-enriched liquid rise up from the boundary of the inner core, drifting upward through the entire outer core. And this rising drives convection just as powerfully as heat does, perhaps even more efficiently in fact, because unlike thermal buoyancy, it does not lose its punch to the fluid cooling along the way. Let me draw out that last point, because it is the quiet reason compositional buoyancy may be the more important engine of the two. Think about what can go wrong with thermal buoyancy. When a hot parcel of metal rises, it carries its extra heat with it. But heat is a slippery thing. It leaks. As the hot parcel climbs, it is constantly conducting some of its warmth sideways into the cooler metal around it, bleeding away the very temperature difference that makes it buoyant in the first place. Given enough time, a rising hot blob can simply cool off, lose its lift, and stall before it gets very far. Heat does not stay put. Now compare that to a parcel enriched with light elements. Those light elements are not a temperature. They are matter, actual atoms of oxygen or sulfur or silicon dissolved into the metal. They cannot conduct away sideways the way heat does. Once a parcel is lighter because it is chemically different, it stays lighter all the way up. Its buoyancy does not leak. So the compositional plumes rising from the inner core boundary can drive convection more steadily and more efficiently than thermal plumes, punching all the way through the outer core without fizzling out along the way. It is the difference between a lift that slowly deflates and a lift that holds. Step back and appreciate what the inner core is doing here. Simply by slowly freezing and growing, it is running two engines at once. It releases latent heat, boosting thermal convection, and it expels light elements, driving compositional convection. Both of these stir the outer core. Both of these keep the ocean of metal in the vigorous motion the dynamo depends on. That quiet, slow crystallization at the center of the Earth, adding a hair's width of solid iron a year, is one of the most important power sources keeping your compass pointing north. So now we have found two engines: thermal cooling and buoyancy, and the freezing of the inner core with its latent heat and its rising light elements. Are those the only sources? Not quite. There is at least one more contributor we need to mention, and we need to handle it with care because it is often overstated. Deep inside the Earth, there are radioactive elements, things like certain forms of potassium, uranium, and thorium. As these elements decay, they release energy, and that energy appears as heat. Radioactive decay is a genuine source of warmth inside the planet, and it contributes to Earth's overall internal energy budget, helping to keep the interior hot and slowing the rate at which everything cools. There is a genuine reason this energy accounting has become such an active puzzle in recent years, and it is worth a moment because it shows science correcting itself in real time. For a long time, researchers made certain assumptions about how well iron in the core conducts heat. Then, newer work suggested that the iron down there might actually conduct heat considerably better than anyone had thought. That sounds like a dry, technical detail, but it has a sharp consequence. If the core conducts heat unusually well, then a lot of heat can escape from the core just by ordinary conduction, quietly, without any churning at all. And heat that leaks out by simple conduction does not stir the fluid. It does no work for the dynamo. This tightened the whole energy budget uncomfortably, because it meant less of the core's heat loss was left over to actually power convection. That squeeze is a big part of why scientists now lean so heavily on the freezing inner core, with its latent heat and especially its light element buoyancy, to make up the difference and keep the dynamo running. The exact numbers are still being argued over, measurement against measurement, and this is precisely the kind of open, unsettled accounting that honesty about the science demands we acknowledge rather than paper over. The framework is solid. The bookkeeping is still being balanced. But here is the important caution. It is tempting to seize on radioactivity as the tidy, obvious answer, a nuclear furnace at the center of the Earth powering everything. That picture is too simple and probably wrong, at least as a complete explanation. The amount of radioactive heating actually present in the core, and how much of it drives the dynamo specifically, is genuinely uncertain and remains an active area of research. It may play a meaningful supporting role. It is not clearly the dominant power source of the dynamo, and it certainly is not the whole story. The heavyweight engines are the ones we already met, the cooling of the planet and the freezing and growth of the inner core. Radioactivity is best understood as one contributor among several to Earth's energy budget, not the star of the show. Honest science means resisting the neat single answer when the real system is a blend of several sources whose exact balance we are still working out. So, we have our power supply. A cooling planet shedding its ancient heat, a freezing inner core pumping out latent heat and light elements, and a background contribution from radioactive decay. Together, these drive the convection that keeps the outer core churning. Case closed? Not yet, because there is a subtle and absolutely essential piece we have been ignoring, and without it, all of that energy would be useless. It is not enough for the core to contain heat. The heat has to be able to get out, and whether it can get out, and how fast, is controlled not by the core at all, but by the enormous layer sitting on top of it, the mantle. Here is the point that trips people up. Convection in the outer core does not run on how much heat the core has stored. It runs on how fast the core is losing heat. Those are different things. Think again about the pot of water. If you put a lid on it and then wrap the whole pot in thick insulation, the water inside stays hot, but the convection weakens because heat can no longer escape efficiently from the top. The circulation is driven by the temperature difference between top and bottom, and if you trap the heat, that difference shrinks and the churning slows. Vigorous convection requires that heat actually be carried away efficiently at the top. Bottle it up, and the engine stalls even though the fluid is still hot. The outer core faces exactly this situation. It is trying to shed heat upward, but it can only shed that heat as fast as the mantle above it is willing to carry it away. The mantle is the lid on the pot. If the mantle draws heat out of the core efficiently, the core stays in vigorous convection and the dynamo runs strong. If the mantle insulates the core, holding the heat in, convection weakens and the dynamo falters. So the mantle, that vast layer of slowly flowing rock we set aside earlier, turns out to be the gatekeeper of the whole magnetic field. It controls the tap. And the mantle is not uniform. This is where it gets fascinating. The mantle has structure. It is churning in its own extraordinarily slow convection over hundreds of millions of years, and as a result, some regions of the deep mantle are hotter and some are cooler. Some regions carry heat away from the core efficiently, others less so. There are vast provinces down near the base of the mantle, right at the core mantle boundary, where the rock is unusually hot and behaves differently, and other regions where cold slabs of old ocean floor have sunk all the way down and pile up against the core, drawing heat out more greedily. This means the core is not losing heat evenly all over its surface. In some places, the mantle above pulls heat out fast. In others, the mantle holds it in. And that uneven pattern of heat loss across the top of the core actually shapes the pattern of convection down in the liquid metal, which in turn influences the structure and behavior of the magnetic field itself. The geography of the deep mantle leaves its fingerprints on the geography of the magnetic field. Changes in how the mantle removes heat, playing out over tens and hundreds of millions of years, may even be connected to long-term changes in how the dynamo behaves. But I want to keep the mantle firmly in its place in our story. It is the gatekeeper, the regulator of the heat flow that powers the dynamo. It sets the terms under which the outer core operates. It is not itself the generator. The mantle is rock, not liquid metal, and it does not generate the field. Its job is to control how efficiently the core can cool, and that is a supporting role, however important. We will not wander off into the deep and wonderful geology of the mantle, because our target is the dynamo, and the mantle matters to us only as the valve on the core's heat. Let's assemble the full engine room now, because we have gathered all the pieces and they fit together into a single, coherent machine. Earth was born hot and is slowly cooling. Heat flows outward from the hot core toward the cool surface. That heat loss drives thermal convection in the liquid outer core, hot metal rising, cool metal sinking. Reinforcing this, the solid inner core is slowly freezing and growing as the planet cools, and this freezing releases latent heat that adds to the thermal drive. At the same time, the freezing expels lighter elements into the liquid, which rise buoyantly and drive a second, compositional convection, arguably the more efficient of the two. Radioactive decay adds a modest, uncertain background of heat to the overall budget, and overseeing all of it, the mantle acts as the gatekeeper, controlling how quickly the core can shed its heat, with its own uneven structure shaping where and how vigorously the core convects. The output of all this is the one thing the dynamo cannot do without: vigorous, sustained, three-dimensional motion of an enormous body of electrically conducting liquid metal. That is the falling water. That is the fuel. Feed that motion into the self-sustaining loop we built earlier, motion generating currents, currents generating field, field organizing motion, and you have a magnetic field that regenerates itself faster than it decays, for as long as the engines keep running. and now we can appreciate why the field has lasted billions of years rather than tens of thousands. It is because these energy sources are not quick or fleeting. A planet cooling from the heat of its formation cools over billions of years, not thousands. An inner core freezing outward grows over billions of years. These are some of the slowest, most patient processes in nature, and that slowness is precisely the point. The dynamo has been paid for continuously across almost the entire life of the Earth, because the Earth has had a continuous supply of energy to pay with, drawn from its own enormous store of primordial heat and from the endless, slow freezing at its heart. But notice something we have quietly assumed and not yet justified. We have said that convection, this rising and sinking of hot and cool, light and heavy metal, drives the dynamo. Yet convection, by itself, is a fairly disorganized affair. Plumes rise here, sink there, in a churning, chaotic tangle. If you just had raw, random churning, would that actually produce the beautifully organized, planet-spanning magnetic field that your compass responds to? The one with a clear north and south, reaching out into space in a recognizable shape? Or would it just produce a magnetic mess, a jumble of little fields pointing every which way, cancelling each other out? This is a genuine and deep problem. Random turbulence, on its own, does not obviously build a stable, large-scale, organized field. Something has to take that chaotic convective motion and organize it, shape it, give it a preferred structure, so that instead of 1,000 tiny fields fighting each other, you get one grand coherent field for the whole planet. There has to be an organizing hand in the churning metal, and there is. That organizing hand is the rotation of the Earth itself. The very fact that our planet spins once a day turns out to impose a hidden order on the chaotic convection, twisting and aligning the flow into structured patterns that allow a coherent global field to emerge. How a simple daily spin can tame an ocean of turbulent molten iron, and how the shaped flow then closes the loop to actually build and amplify the field it needs, is where our journey turns next. We have built the engine and found its fuel. Now we have to see what organizes its motion, and how motion finally becomes magnetism that can hold itself together. We left the engine running but disorganized. We have an ocean of molten iron churning with vigorous convection, powered by a cooling planet and a freezing inner core. We have the raw motion the dynamo needs. But we were left with a troubling doubt. Raw convection is chaotic. Plumes rise here, sink there, in a tangled, turbulent mess. And a chaotic mess of motion does not obviously add up to the clean, organized, planet-spanning magnetic field that swings your compass northward. If anything, you would expect pure chaos to produce a magnetic jumble, countless tiny fields pointing in random directions, all fighting and cancelling one another until nothing coherent survives. So something has to bring order to the chaos. Something has to take that churning and shape it, organize it, give it a grain, a preferred direction, a structure, so that a single grand field for the whole planet can emerge instead of 1,000 squabbling little ones. And the source of that order is not down in the core at all. It is the whole planet, turning. It is rotation. Earth spins once a day. We feel none of it, but that steady rotation reaches all the way down into the liquid metal of the outer core and imposes a hidden order on everything moving there. To understand how, we need to meet a force that is not really a force at all, but that shapes the motion of every large, flowing thing on a rotating planet, from hurricanes in the atmosphere to currents in the ocean to the molten iron in the core. It is called the Coriolis effect. Let me give you the most intuitive picture I can. Imagine you are standing at the center of a large, slowly spinning merry-go-round, and you try to roll a ball straight out to a friend standing at the edge. You aim carefully. You release the ball in a perfectly straight line, and yet, from your point of view on the spinning platform, the ball does not travel straight. It curves off to the side. You did nothing wrong. The ball really did travel straight through space. But while it was traveling, the platform beneath it rotated, so your friend moved, and the whole spinning frame you are standing in shifted underneath the ball's path. Relative to the rotating platform, the straight line motion looks curved. That apparent curving of anything that moves across a rotating body is the Coriolis effect. On Earth, because the planet is spinning, anything that moves over long distances, air, water, molten metal, gets deflected sideways from the path it would otherwise take. In the northern half of the planet, it tends to veer one way, in the southern half, the other. It is why great storm systems spiral rather than simply rushing straight inward, why ocean currents wheel around in vast curves. And it is why the convection in the outer core cannot rise and sink in simple straight plumes. Every rising and sinking motion in that liquid metal gets twisted sideways by the planet's rotation. Now here is the beautiful consequence. When you take convection, which wants to move fluid up and down between the hot bottom and the cool top, and you subject it to the relentless sideways twist of the Coriolis effect on a rapidly rotating planet, the flow does not stay disorganized, it self-organizes. Instead of a random churn, the rotation herds the motion into tall, elongated, twisting structures, great rolling columns of fluid aligned roughly along the direction of the planet's axis, the line running from the North Pole to the south. Picture a set of long, spinning corkscrews of liquid metal standing more or less upright inside the outer core, parallel to Earth's spin axis, each one churning and twisting as it rises and sinks. This is the key transformation. Rotation takes the shapeless energy of convection and forges it into organized, coherent, twisting columns. And organized, coherent motion is exactly what you need to build an organized, coherent magnetic field. The chaos has been given a grain. The turbulence has been given a preferred direction. The daily spin of the Earth is the invisible hand combing the tangled metal into ordered streams. But I have to be very careful here, because it is easy to overreach and draw the wrong conclusion. It would be tempting to say, aha, rotation creates the magnetic field. It does not. Rotation, by itself, generates no magnetism whatsoever. A spinning ball of liquid metal with no convection and no seed field would produce no dynamo at all. Rotation is not the power source, and it is not the generator. What rotation does is organize and stabilize the flow that the convection provides. It shapes the motion into a form from which a large-scale field can be built and held together. Think of it this way. Convection supplies the muscle, the actual moving of the metal, powered by heat and buoyancy. Rotation supplies the discipline, arranging that muscle into orderly, structured motion. You need both. Muscle without discipline is a flailing mess that builds nothing lasting. Discipline without muscle is just an empty rulebook with nothing to organize. So let us be precise about the ingredients, because this is the crux of the whole mechanism. To build and sustain a planetary magnetic field, you need three things working together, and no one of them alone is enough. First, you need vigorous convection, the moving of a conducting fluid powered by an energy source. Second, you need that fluid to be an excellent electrical conductor, which molten iron is. And third, you need rotation to organize the convective flow into coherent, large-scale structures. Convection, conductivity, and rotation. Remove any one, and the dynamo fails or produces only a feeble, disorganized field. Together, they make a planetary magnet. This is why the honest statement is never rotation makes the field or convection makes the field, but rather that these ingredients must operate in concert. The field is a collaboration. We have now organized the flow. But we still have not actually shown the most important thing of all, the thing that makes a dynamo a dynamo. We have not yet shown how this beautifully structured motion actually takes a magnetic field and amplifies it, strengthens it, rebuilds it, feeding it back into itself so it never dies. We have the organized muscle. Now we have to watch it lift the weight. We have to watch motion become magnetism that can hold itself up. To see this, we return to the two links of induction we learned earlier, but now we apply them inside those twisting columns of metal. And we start with a question. If a magnetic field can only be generated by the motion of a conductor through an existing magnetic field, then where does the first field come from? Doesn't the dynamo need a magnetic field before it can make one? Isn't this a chicken and egg problem? The answer is wonderfully unfussy. The universe is full of weak magnetic fields. Space itself is threaded with faint magnetism. The early Earth would have been bathed in stray magnetic fields from all sorts of sources. There is always some small seed magnetic field lying around to get things started. The dynamo does not need to create a field from absolutely nothing. It only needs to grab hold of a tiny, pre-existing disturbance and then amplify it, grow it, multiply it into the powerful, global field we have today. The genius of the dynamo is not creation from nothing, it is amplification. It is taking a whisper and turning it into a roar. So how does the amplification work? This is where we need one more idea, and it is a lovely one. When a magnetic field passes through a very good conductor that is moving, the field lines behave almost as if they are frozen into the fluid and carried along with it. Let me be careful with that phrase, frozen into, because it is a picture, not a literal truth, and I will come back to warn against taking it too far. But as an image, it is powerful. In a highly conducting fluid in motion, the magnetic field gets dragged along with the flow, stretched where the fluid stretches, bent where the fluid bends, wound up where the fluid winds up. Now watch what the organized motion does to a magnetic field carried along with it. Two things, above all. The first is stretching. Imagine a magnetic field threading through the outer core, and imagine a stream of fluid that grabs a piece of that field and pulls it, stretching it out longer and longer, the way you might pull a piece of dough into a long, thin strand. Here is the crucial physics. When you stretch a magnetic field line in a conducting fluid, you concentrate and intensify the field. Stretching a field makes it stronger. So the flowing metal, by stretching the field lines threaded through it, actively amplifies the magnetic field. It takes a given amount of magnetism and, by drawing it out, makes it more intense. This is the beating heart of amplification. Motion stretches field, and stretched field is stronger field. The second is twisting and folding. Remember those rotating columns, corkscrews of fluid turning as they rise and sink? That twisting motion takes the field lines and twists them too. And twisting is enormously important because it can take a field pointing in one direction and rotate part of it to point in a new direction. This lets the dynamo do something essential. It lets it take field of one type and generate field of another type, and then convert it back again. By twisting, the flow can regenerate the very components of the field that are constantly being lost, closing the loop. And folding does something clever as well. If you stretch a field to make it stronger and then fold it back on itself so the strengthened pieces stack up and reinforce one another, pointing the same way, you build the field up even further, like folding a strip of hot metal over and over to build a stronger blade. I want to slow down on the twisting for a moment because there is a subtlety inside it that is the real machinery of self-regeneration, and it is easy to skate past. Picture the field in the core as having two different characters it can take. In one character, the field wraps around the axis of the planet, running in great circles the way lines of latitude run around a globe, east to west. In the other character, the field arcs up and over from pole to pole, the way lines of longitude run, the way the simple bar magnet field we picture at the surface behaves. Now here is the beautiful part. The churning columns of metal can convert one of these characters into the other and back again. When fluid shears and drags the pole-to-pole field around the spinning planet, it wraps that field into the circling east-west character, generating one type from the other. And then the twisting, corkscrewing motion of the rising columns takes that circling field and lifts and rotates loops of it back up into the pole-to-pole character, regenerating the very type that was steadily leaking away. Each character feeds the other. The flow keeps cycling the field between these two forms, and in doing so, it continually rebuilds whichever part is being lost, closing the loop and keeping the whole structure standing. It is this endless conversion, one character of the field constantly being spun into the other, that lets a churning fluid regenerate a complete field indefinitely, rather than just amplifying one piece of it once and then watching it decay. Put these together, stretching to intensify, twisting to redirect and regenerate, folding to reinforce, and you have a machine that does not merely carry a magnetic field around passively, it actively multiplies it. A weak seed field, threaded into this churning, twisting, stretching, folding ocean of conducting metal, gets amplified, redirected, and reinforced, growing stronger and more organized until it becomes the powerful, coherent, planetary field we live inside. The organized motion, powered by convection and shaped by rotation, is constantly regenerating and rebuilding the magnetic field from within. The whisper becomes a roar. Now I owe you that warning about frozen-in field lines, because this is a place where a helpful picture can quietly mislead. When I talk about field lines being stretched and twisted and folded like strands of dough or ropes of metal, please do not imagine that there are actual physical strings or wires down there in the core. There are not. A magnetic field is not made of threads. Field lines are a visualization, a way for us to draw and picture the direction and strength of the field at each point in space. Where the imaginary lines are drawn closer together, the field is stronger. The direction of a line shows the direction of the field. They are an enormously useful bookkeeping device, a map of an invisible thing, but they are not objects. Nothing in the core would snap or twang if you could reach in and pluck one, because there is nothing there to pluck. So, when we say the flow stretches and folds the field lines, we mean the flow reshapes the invisible field, and the lines on our map move to show it. Keep the map and the territory separate in your mind, and the picture serves you well. Confuse them, and you will start imagining a core full of tangled spaghetti, which is not what is there. With that caution in place, we can now confront the single most important question in this entire story, the one that everything has been building toward. Why does the field need to be regenerated at all? Why can't the dynamo build the field up once and then coast? Why must this stretching and twisting and folding go on forever without pause? The answer takes us right back to the paradox we opened with, and now we can finally understand it deeply. The reason is electrical resistance. No conductor is perfect, not even molten iron. When electric currents flow through the outer core, they encounter resistance, and that resistance continuously drains energy out of the currents, dissipating it as heat. And since the magnetic field is held up entirely by those currents, as the currents lose energy to resistance, the magnetic field they support constantly leaks away. There is a name for this slow bleeding of magnetic structure. The field diffuses, spreading out and weakening, decaying over time. This is the very decay we met at the very beginning, the reason a field left to itself would fade in a geological blink. So here is the true picture of Earth's magnetic field, and it is nothing like a static shield hanging permanently in place. The field is under constant attack from within. Electrical resistance is perpetually dissolving it, dissipating its energy, dragging it toward oblivion. And at the very same time, the churning, rotating, stretching, twisting, folding motion of the outer core is perpetually rebuilding it, regenerating the magnetic structure as fast as resistance destroys it. The field you feel today is not the field of yesterday preserved. It is a field being demolished and reconstructed continuously, moment by moment, in a ceaseless race between decay and regeneration. This is what it truly means to call the field alive. Now we can say it precisely. The field is not alive in any biological sense. It does not breathe or grow or reproduce. And it is emphatically not alive in the sense of being unchanging or permanent. When we say the field is alive, we mean it is dynamically maintained. We mean it is being actively regenerated, continuously, by an ongoing process that must never stop. A candle flame is alive in exactly this sense. The flame you see is not a fixed object. It is a process, a continuous burning, matter and energy flowing through it, the flame remade every instant. Blow it out, stop the process, and it is gone at once. Earth's magnetic field is a flame in exactly this way. It persists not by being preserved, but by being perpetually remade. The dynamo continuously replaces the magnetic energy that resistance continuously destroys. That balance, that endless replacement, is life for a magnetic field. And this immediately tells us why the field can survive for billions of years, while its natural decay time is only tens of thousands. Both things are true at once. Yes, if regeneration ever stopped, the field would decay away in a geological instant. But regeneration has not stopped. It has been running continuously for almost the entire age of the planet, because the energy sources that drive it, the cooling of the Earth and the freezing of the inner core, have themselves been running continuously for that whole time. The field's short natural lifespan is not a contradiction of its long actual survival. It is the result is so remarkable. The field is short-lived by nature and long-lived in practice, and the only thing bridging that gap is a dynamo that has never once, for 4.5 billion years, been allowed to rest. Now I want to add one more layer, because so far I have described the relationship between motion and magnetism as if it flows only one way. Motion makes field, field decays, motion remakes it. But the real system is subtler and more interesting than a one-way street. I'm getting this right is what separates a cartoon of the dynamo from the real thing. The magnetic field does not just passively sit there being generated by the flow. The magnetic field pushes back on the flow that generates it. A magnetic field exerts forces on moving electrical currents and on the conducting fluid carrying them. So as the dynamo builds up a strong field, that strong field begins to press against the very motions of the metal, nudging them, resisting some of them, redirecting others, reshaping the convective columns that are busy generating it. The flow shapes the field, and the field, in turn, shapes the flow. Each influences the other, continuously, in both directions. This two-way relationship has a name. It is the domain of magnetohydrodynamics, which is a long word that simply means the physics of electrically conducting fluids in motion interacting with magnetic fields. And the feedback between flow and field is magnetohydrodynamic feedback. You do not need to memorize the term. You only need to hold on to the idea. The dynamo is not a one-way chain where motion produces field and that is the end of it. It is a coupled system, a genuine partnership, a conversation between the moving metal and the magnetism, each constantly responding to the other. The field the flow creates then talks back to the flow, altering it, and the altered flow then alters the field, around and around, forever. This coupling is part of what makes the real dynamo so fabulously complicated and so difficult to fully predict. It is not a simple loop turning smoothly like a single wheel. It is turbulent. It is three-dimensional. It is time-dependent, always changing. And it is shot through with this feedback, where cause and effect chase each other in both directions. When you hear later that the field's strength varies, that its poles wander, that it even flips upside down from time to time, this coupled, feedback-laden complexity is the deep reason why. A simple one-way machine would produce a steady, boring output. A coupled, turbulent, feedback-driven system produces something restless and surprising, which is exactly what Earth's field turns out to be. There is one more concept I want to introduce, gently, because it captures in a single idea whether a dynamo will actually work. And it will matter when we later ask why some worlds have fields and others do not. Remember that two things are happening at once in the core. The motion of the fluid is trying to carry and regenerate the magnetic field, stretching and twisting and rebuilding it. And electrical resistance is trying to let the field diffuse away, spreading and decaying it. These two processes are in a race: regeneration versus decay, building versus bleeding. Scientists capture this race in a single measure, a way of asking which process is winning. It is called the magnetic Reynolds number, and I will not burden you with any formula, because the formula is not the point. The idea is what matters, and the idea is simply this. The magnetic Reynolds number is a measure of whether the motion of the fluid carries and regenerates magnetic structure faster than resistance lets it diffuse and decay away. If the motion wins, if the fluid can rebuild the field faster than it leaks away, then the dynamo can sustain itself and grow its field. If decay wins, if the field diffuses away faster than the sluggish motion can rebuild it, then no self-sustaining dynamo is possible, and any field simply fades. So this single idea, motion versus diffusion, regeneration versus decay, is the tipping point that decides whether a churning ball of conducting fluid becomes a planetary magnet or stays magnetically dead. For Earth's outer core, the motion wins, and wins comfortably, which is why we have a field at all. I will resist quoting any exact numerical threshold, because the real conditions inside the Earth are complex, and the precise numbers are the province of ongoing, careful research. The concept is the durable thing to carry forward. Does motion outrun diffusion? For our planet, yes. So let us gather everything we have built up to here, because we have now, at last, assembled the complete working dynamo. Convection, powered by the cooling planet and the freezing inner core, provides vigorous motion in the electrically conducting liquid metal. Earth's rotation, through the Coriolis effect, organizes that chaotic motion into coherent, twisting columns aligned with the spin axis, giving the flow a grain from which a large-scale field can be built. The organized flow seizes a small seed magnetic field and amplifies it, stretching the field to intensify it, twisting it to regenerate its lost components, folding it to reinforce itself, growing a whisper into the roar of a planetary field. Electrical resistance perpetually drains that field away, so the regeneration can never stop, and the field survives only by being continuously rebuilt as fast as it decays, replaced exactly as quickly as it is lost. And the whole thing is coupled, a two-way conversation in which the field pushes back on the flow that makes it, producing a turbulent, restless, endlessly changing system whose self-sustaining success comes down to a single question: where the motion regenerates structure faster than diffusion erases it. That is the dynamo. That is the machine that has kept the shield around our world alive since before there was life to shield. But notice the word I keep returning to: restless, changing. This is not a steady, reliable, unchanging magnet. It is a turbulent, coupled, feedback-driven system, and turbulent coupled systems do surprising things. They do not hold perfectly still. And indeed, when we look at the actual behavior of Earth's field across time, we find it is anything but constant. Its strength rises and falls. Its poles wander across the globe. And every so often, in one of the most astonishing behaviors in all of geophysics, the entire field flips upside down, north becoming south and south becoming north, without the dynamo ever switching off. Why a self-sustaining dynamo should be so restless, what a magnetic reversal really is and is not, how we can possibly read this history in ancient stone, and why some worlds run out of magnetism while ours keeps going, is where our journey comes to its close. That word keeps echoing, doesn't it? Restless. We have built a dynamo that is turbulent, coupled, driven by feedback. A machine in which the flow shapes the field and the field shapes the flow in an endless conversation. And a machine like that does not sit still and hum along at a fixed pitch. It wanders, it surges and sags, and every so often it does something so dramatic that it took scientists a long time to even believe it was real. It turns the entire planetary field upside down. So let us finally look at how Earth's field actually behaves across time, because the reality is far stranger and far more alive than the tidy image of a steady bar magnet buried in the ground. Start with the simplest kind of restlessness. The magnetic poles move. And here I need to draw a distinction that trips up almost everyone: the difference between the geographic poles and the magnetic poles. The geographic North Pole is a fixed point, the spot where Earth's axis of rotation meets the surface, the top of the spinning globe. It does not wander. It is defined by the spin. But the magnetic North Pole, the place a compass needle actually points toward, the place where the field dips straight down into the ground, is a completely different thing. It is set by the dynamo, by the pattern of currents in the churning core. And because that pattern is always shifting, the magnetic pole is always on the move. This is not a subtle, invisible drift. The magnetic North Pole has been clocked wandering across the Arctic at a real and measurable pace, drifting over the years, sometimes speeding up, sometimes slowing, tracing a restless path that has been carefully tracked for a very long time. Navigators and mapmakers have to account for it constantly, updating their charts, because the direction your compass points slowly changes decade by decade. The geographic pole stays put. The magnetic pole roams. They are simply not the same thing, and the roaming of the magnetic pole is a direct, visible symptom of the ever-shifting flow in the core beneath. The field's strength changes too. It is not a fixed quantity. Over the centuries and millennia, the overall intensity of Earth's magnetic field rises and falls. In recent times, the global field has actually been weakening somewhat, and there are regions where it is notably weaker than elsewhere. This does not mean anything is broken. A dynamo whose strength wobbles up and down over time is behaving exactly as a turbulent coupled system should. The strength of your compass's guide is not a constant of nature. It breathes. But the pole wandering and the strength changes, remarkable as they are gentle compared to the headline act. Because sometimes the field does not merely weaken or drift. Sometimes it reverses. The North Magnetic Pole and the South Magnetic Pole trade places. A compass that once pointed north would, after a reversal, point south. The entire global magnetic field flips its polarity, top to bottom. This sounds almost unbelievable, and yet we know beyond any doubt that it has happened, not once, but many hundreds of times across Earth's history. The field has flipped again and again over the eons, sometimes staying in one orientation for a few tens of thousands of years, sometimes holding steady for millions before flipping again. The pattern is irregular. There is no neat clock ticking off reversals at fixed intervals. They come when they come. The last full reversal was a very long time ago by human standards, hundreds of thousands of years in the past, long before recorded history. And there is no way to know from the record when the next one will arrive. Now, here is where I have to be extremely careful, because reversals are surrounded by more misunderstanding and more exaggeration than almost any other topic in Earth science. Let me strip away the myths one at a time. First myth: a reversal does not mean the dynamo switches off. This is crucial. When the field flips, the engine in the core does not stop. The convection keeps churning. The rotation keeps organizing. The dynamo keeps regenerating. A reversal is not a death and rebirth of the field. It is a rearrangement of a field that stays alive throughout. The self-sustaining machine never shuts down. It simply reorganizes into the opposite orientation. Think of it less like a light bulb burning out and being replaced, and more like a spinning top that wobbles and reorients without ever stopping spinning. So where do reversals come from, if not from the dynamo failing? They come from the very complexity we have been building toward this whole journey. Remember, the flow in the core is turbulent, three-dimensional, and coupled to the field through feedback. A system like that is inherently prone to instabilities. The organized field the dynamo maintains is not guaranteed to be stable forever. Now and then, the chaotic churning and the feedback between flow and field conspire to destabilize the existing arrangement, and the field can lose its coherent structure, weaken, become tangled and complex, and then reassemble itself, sometimes in the same orientation it started in, and sometimes flipped. Reversals, in other words, are not imposed from outside by some cosmic trigger. They emerge from within, out of the natural instabilities of a complex, turbulent dynamo. They are something the system does to itself. Second myth, and this one matters for how you feel about the whole idea. A reversal is not, by default, a global catastrophe. There is a popular image of a reversal as an apocalyptic event, the sky falling, disaster everywhere. The honest scientific picture is far more measured. During a reversal, the field does weaken and become more complex. Instead of one clean, strong, roughly bar magnet-like arrangement, the field during a transition can become jumbled, with multiple weaker poles scattered around the globe and a reduced overall strength for a time. That is a genuine change, and it would have real consequences for anything that relies on the field, which we will get to. But the fossil record does not show reversals lining up with mass extinctions. Life has weathered hundreds of these flips. The most honest thing to say is that a reversal is a significant, temporary weakening and reorganization of the field, not an automatic doomsday. And I will resist the temptation, which some do not, to tell you exactly when the next one is coming. No one can predict the timing of the next reversal. The dynamo is too complex, too turbulent, too sensitive for that kind of forecast. We know reversals happen. We cannot say when the next one will be. Now, to talk about what the field does out in space and why its weakening during a reversal matters at all, I need to correct one more common oversimplification. the picture of the field as a perfect bar magnet. Most of the time, Earth's field, seen from a distance, looks approximately like the field of a simple bar magnet, what scientists call a dipole, meaning it has essentially two poles, a north and a south, with the field arcing smoothly from one to the other around the planet. This dipole picture is a good first approximation, and it is why a compass works so reliably. But it is only an approximation. The real field is the dipole, plus a whole collection of smaller, messier, more complex components layered on top. There are regional patches where the field is stronger or weaker, or points in unexpected directions, wrinkles and lumps in the overall pattern. So the field is approximately dipolar, dominated by that simple two-pole structure, but it is not a perfect bar magnet. It is a grand, smooth dipole, with a texture of smaller complexities riding along with it. And during a reversal, it is precisely the clean dipole part that weakens and breaks down, leaving the messier components more exposed, which is why the field gets so tangled and complicated during the flip. Let us follow that field out beyond the surface, into space, because this is where the field does the job that matters most for us. The dipole field does not stop at the ground. It reaches thousands of kilometers out into space, forming a vast magnetic bubble around the planet. But that bubble is not floating in an empty void. It is being constantly buffeted by something streaming out from the sun. The sun blows a continuous wind of charged particles out into the solar system, a thin, fast stream of electrically charged matter called the solar wind. It rushes outward in all directions, and it slams into everything in its path, including Earth. And here is where the magnetic field earns its keep. Because these solar wind particles are electrically charged, and because magnetic fields exert forces on moving charges, Earth's magnetic field can push on them, deflecting many of them, steering them around the planet rather than letting them plough straight into us. The result of this collision between the solar wind and Earth's field is a beautifully sculpted structure called the magnetosphere. And I want to be precise about what shapes it, because it is a genuine partnership. The magnetosphere is not just Earth's field sitting there in a neat, symmetrical bubble. It is Earth's internal field pushing outward, and the solar wind pushing inward, the two forces meeting and shaping each other. On the side facing the sun, the solar wind compresses the field, squashing the bubble inward. On the side facing away, it stretches the field out into a long, trailing tail, streaming away from the sun for an enormous distance. So the magnetosphere is shaped jointly, by the field the dynamo generates from within, and by the charged particles arriving from the sun without. Both sculptors, one shape. And this is where I have to guard against the single most common exaggeration of all, the claim that Earth's magnetic field is a shield that blocks all the sun's harmful radiation, and that without it, life would be impossible. That claim is popular, dramatic, and not quite right, and getting it right actually deepens your appreciation of what the field really does. Here is the careful version. The magnetic field deflects many charged particles, the electrically charged bits of the solar wind, and some of the charged cosmic particles from deeper space. That is real and valuable. But the field does not and cannot block electromagnetic radiation. Visible light, ultraviolet light, and other forms of electromagnetic radiation are not electrically charged particles. They are not deflected by magnetic fields at all. Sunlight pours straight through the magnetosphere as if it were not there, which is exactly why you can see the sun and feel its warmth. So the magnetic field is a shield against certain charged particles, not a shield against all radiation. It is essential to distinguish charged particle deflection from protection against light and ultraviolet radiation. The field handles the former. It does essentially nothing about the latter. So what protects us from the sun's ultraviolet radiation, the kind that can damage living tissue? Overwhelmingly, that job belongs not to the magnetic field, but to the atmosphere, and particularly to certain gases high in the atmosphere that absorb ultraviolet light. The atmosphere is a major protective layer in its own right, and for electromagnetic radiation, it is the main defense, not the magnetic field. In fact, the atmosphere and the magnetic field work as a team with a division of labor. The field deflects many charged particles. The atmosphere absorbs much of the dangerous ultraviolet, and it also burns up most of the small debris that constantly rains in from space. Neither one alone does everything. This is why I want to gently push back on the sweeping claim that life could not exist at all without the magnetic field. It is an overstatement. The field is genuinely helpful. Over very long timescales, deflecting the solar wind may play a role in protecting the atmosphere itself, a benefit we will see written plainly across the face of another world before we are done. But it is too strong to declare flatly that no life anywhere could survive without a magnetic field. Life is more resourceful than that, and the atmosphere carries much of the protective load. The truthful statement is that Earth's magnetic field is one valuable layer of protection among several, working alongside the atmosphere, not a single all-powerful force field standing between us and certain death. Give it the real credit it has earned, deflecting charged particles and helping preserve the atmosphere over eons without inflating it into something it is not. Now, one of the loveliest and most useful consequences of the field's interaction with the solar wind deserves a mention, because it also connects to how we know any of this. When the solar wind is especially strong, and charged particles do get funneled down along the field toward the polar regions, they crash into the upper atmosphere and make it glow, producing the shimmering curtains of light we call the aurora, the northern and southern lights. The aurora is, in a sense, the visible signature of the magnetosphere at work, the field guiding charged particles down toward the poles where they light up the sky. It is a beautiful reminder that the invisible field is doing something real every single day. But how do we know the field has behaved this way across billions of years, when there were no scientists, no compasses, no instruments to record it? How can anyone possibly claim that the field has reversed hundreds of times, or that it has existed for most of Earth's history? The answer is one of the most elegant pieces of detective work in all of science, and it is written into the rocks themselves. Here is the key idea. Certain rocks, when they form, record the direction and strength of Earth's magnetic field at the moment of their formation, and then they keep that record frozen in place for millions or billions of years. This is called paleomagnetism, the study of ancient magnetism preserved in stone. The way it works is this. Many rocks, especially those born from cooling molten material like lava, contain tiny grains of magnetic minerals. When the rock is hot, above a certain temperature, those little magnetic grains are free to swivel and align themselves with whatever magnetic field surrounds them at the time, which is Earth's field. Then, as the rock cools and hardens, the grains lock into place, frozen in the direction they were pointing. They become a permanent record, a fossilized compass reading, capturing the direction of Earth's field at the exact moment that rock solidified. So, when scientists find rocks of different ages and read the frozen magnetic directions inside them, they can reconstruct what Earth's field was doing across enormous spans of time. And this is exactly how we know about reversals. When they line up rocks by age and read their frozen compasses, they find long stretches where the rocks point one way, then a switch to rocks pointing the opposite way, then back again, over and over through the layers of geological time. The rocks themselves testify to the flipping of the field. Nobody had to be there to watch it. The stone remembered. And this is also how we know the field is genuinely old, that it has existed and been active for the overwhelming majority of Earth's history. The oldest rocks and mineral grains that preserve a magnetic record point to Earth having had a magnetic field billions of years ago, remarkably early in the planet's life, though just how far back the record reliably reaches is still debated. Paleomagnetism is the evidence that anchors our whole story. It proves the field is not a recent feature and not a constant one. It has existed for eons, and throughout those eons it has changed, wandered, weakened, strengthened, and reversed. I will keep this focused though, because the magnetic record in rocks is bound up with the grand story of drifting continents and shifting plates, and that is a whole separate epic. For us, paleomagnetism matters simply because it is the witness that establishes the field has been alive and restless across deep time. That is the piece we need. So we have a field that is old, active, restless, and self-sustaining, which raises a natural and important comparison. If Earth can run a dynamo for billions of years, why can't every rocky world? Why is Earth special? And here we can finally look outward, briefly, at a few of our neighbours, to see what happens when the delicate recipe for a dynamo goes wrong. Consider Mars. Mars today has no global magnetic field like ours, no active planet-wide dynamo. And yet, remarkably, when spacecraft measured the magnetism frozen into the oldest crust of Mars, they found strong magnetic signatures locked into ancient rock. This is the ghost of a dynamo. It tells us that long ago, early in its history, Mars very likely did have an active dynamo and a global field. But then it stopped. Why? The leading explanation ties back to everything we have learned. Mars is a smaller world than Earth. Smaller worlds hold less internal heat, and, crucially, they lose that heat more quickly relative to their size because they have more surface area compared to their volume. As Mars cooled, its core likely stopped convecting vigorously enough to sustain the dynamo. Without vigorous motion in a conducting fluid, the self-sustaining loop collapsed and the field faded away, leaving only the fossil magnetism in the old crust as a memorial. And Mars carries a further lesson, one that connects back to what the field is for. When Mars lost its dynamo, it did not just lose a compass needle, it very likely lost a slow, long-term guardian of its own air. Remember that one of the genuine benefits of a global field is deflecting the solar wind, that steady stream of charged particles from the sun. Over hundreds of millions of years, an unshielded upper atmosphere is more exposed to that wind, which can gradually strip gas away into space, atom by atom. Mars today is a cold, nearly airless desert, its atmosphere a thin whisper of what the ancient riverbeds on its surface suggest it once had. The full story of how Mars lost its air is complicated, and its small size and weak gravity matter too, so I will not pin the whole tragedy on the dead dynamo alone. But the timing is suggestive. A world that once had a field and rivers and a thicker atmosphere lost the field and then, over the ages, much of the rest. It is a sobering hint of what the invisible engine beneath our own feet may be quietly doing for us across timescales far longer than any human history. Consider Mercury, the smallest planet, closest to the Sun. By the simple logic of size, Mercury should have cooled off and gone magnetically dead long ago. And yet, surprisingly, Mercury does have a global magnetic field today. A weak one, but a real, active one. This is a wonderful puzzle, and it carries an essential lesson. It means size alone does not determine whether a world has a magnetic field. Mercury is tiny, and it should be dead by the crude size rule. But something about the particular state of its core, perhaps a portion of it still liquid and convecting in just the right way, keeps a modest dynamo running. Mercury is the exception that forbids us from ever saying, "small planet, therefore no field." The truth is more subtle. And consider our own moon. The moon today has no global magnetic field, no active dynamo. But once again, the ancient rocks tell a richer story. Samples of old lunar rock carry magnetic signatures suggesting that the early moon may well have had some kind of dynamo in its distant past, which then shut down as the small body cooled and its core solidified or its motion ceased. And there is one more comparison worth making, because it shatters the size rule even more thoroughly than Mercury does. Out among the moons of Jupiter, there is a moon larger than the planet Mercury, a giant among moons, and remarkably, it appears to generate its own magnetic field, produced by a dynamo in its own metallic core. Sit with that for a moment. A moon, orbiting a planet, running its own internal dynamo and wrapping itself in its own magnetic field. If a moon can do it, while far larger rocky bodies cannot, then any lingering temptation to say, bigger means a field, smaller means none, collapses entirely. What matters is not the crude size, but whether that particular body, whatever its size, happens to have a conducting liquid layer still in vigorous, organized motion, still being fed by escaping heat. Some large worlds have gone still and dark. Some surprisingly small ones still turn. The dynamo does not care about rankings. It cares only about liquid, motion, conductivity, and power, all present at once. Put these three neighbours together and you see the real rule, the one that is honest to the complexity. Whether a world has an active magnetic field depends on a combination of factors working together. It depends on the size of the planet and its cooling history, because these govern how much heat is available and how fast it escapes. It depends on the state of the core, whether there is still a liquid, conducting layer in vigorous motion, or whether it has frozen solid or gone still. It depends on the conductivity of that core material, and it depends on whether there is enough internal energy, from cooling, from freezing, from whatever sources, to keep the convection going. No single one of these is the whole answer. Size matters, but Mercury proves size alone does not decide it. Core state matters, energy supply matters, cooling history matters, all of them together. Earth keeps its field because it happens to have all the ingredients at once. A large body still rich with internal heat, a liquid outer core of excellent conductor still in vigorous motion, a freezing inner core pumping in fresh energy, and rotation to organize it all. Change any of those, as Mars and the Moon did, and the field can die. Get an unexpected combination, as Mercury did, and a field can persist where you would not expect it. Before we come home, I want to pause on a note of humility, because the dynamo, for all we understand about it, still guards real secrets, and honesty about the frontier is part of the truth. Here is one of the deepest open questions. We have leaned heavily on the freezing and growth of the inner core as a power source for the dynamo. But the inner core has not always existed in its present form. Early in Earth's history, before the planet had cooled enough, the inner core would have been much smaller, or perhaps had not yet begun to freeze into existence at all. And yet the paleomagnetic record suggests Earth had a magnetic field even in those ancient times, before substantial inner core growth could have been driving things. So the dynamo must have been powered somewhat differently in the deep past than it is today, running on thermal convection and other sources before the compositional engine of inner core freezing switched on. Exactly how the ancient dynamo was powered, and exactly when the inner core began to freeze, are questions still under active investigation. Scientists debate the age of the inner core and the details of the early dynamo, and I will not pretend to a certainty that the research itself does not yet have. What is well established is the framework, the dynamo mechanism itself. What remains genuinely uncertain is the precise balance of energy sources across the whole 4.5 billion years, and how that balance shifted as the planet evolved. And here is the honest limit of our sight. No one has ever seen the liquid metal of the outer core circulating. No one ever will. It is buried thousands of kilometers beneath our feet, under crushing pressure and searing heat, utterly beyond direct observation. We cannot lower a camera down there. We cannot watch the columns turn. Everything we know about the motion in the core is inferred, pieced together from indirect evidence. We measure the magnetic field at the surface and in space, and watch how it changes. We use seismic waves from earthquakes, which travel through the Earth and reveal the layered structure of the core, and the way they do this is genuinely ingenious. When a large earthquake shakes the planet, it sends waves rippling all the way through the interior, and there are different kinds of these waves. One kind can travel through solids, but simply cannot pass through a liquid at all, because a liquid has no rigidity for that kind of wave to push against. So when seismometers all around the globe record an earthquake, scientists find that on the far side of the planet from the quake, there is a great region, a shadow zone, where that particular kind of wave never arrives. Something in the middle of the Earth is swallowing it, blocking it, refusing to let it through. That something is the liquid outer core. The very existence of that shadow, mapped by instruments across the whole surface of the Earth, is how we know the outer core is liquid without ever going there. And the way other waves bend and speed up as they cross into the very center reveals the solid inner core nested inside the liquid. We are, in effect, using earthquakes as a planet-sized X-ray, letting the quiver of a distant tremor draw the outline of a world we can never visit. We build mathematical theory. We run laboratory experiments with spinning, churning liquid metals to see dynamo action in miniature. And we run vast computer simulations that try to model the churning of the core. The laboratory experiments deserve a word of their own, because they are one of the few places we can actually watch dynamo action happen with our own eyes rather than only inferring it. You obviously cannot build a spinning ball of molten iron the size of a planet in a basement. But you can do something clever in miniature. Researchers have built machines that take a large quantity of liquid metal, often liquid sodium, which is an excellent conductor and, unlike iron, is molten at temperatures far easier to handle. And they set that liquid metal spinning and churning inside carefully designed tanks, sometimes driven by powerful propellers or through elaborate systems of pipes. Under the right conditions, with the metal moving fast enough and in the right pattern, these experiments have actually generated their own self-sustaining magnetic fields from nothing but the motion of the fluid. The field appears, grows, and holds itself up, exactly as the dynamo theory predicts it should. Some of these machines have even shown their fields reversing, flipping orientation, a tabletop echo of what the whole planet does over the ages. These experiments cannot come close to the scale or the extreme conditions of Earth's core, and they take enormous engineering effort to run. But every time a churning tank of liquid metal spontaneously turns itself into a magnet, it is a small, hard, physical confirmation that the entire principle we have been describing is real, not just a story that works on paper. But even our best simulations cannot reproduce every detail and every scale of the real Earth exactly. The true core is more turbulent, more finely structured, and operates under more extreme conditions than any computer can fully capture. Simulations and lab experiments are enormously useful. They let us test whether our understanding of the dynamo actually produces the behaviors we see: self-sustaining fields, wandering poles, reversals. And they do. which is powerful confirmation that the framework is right. But no simulation is the Earth. Our picture of the core is a convergence of many separate lines of evidence: magnetic measurements, seismic data, theory, experiment, and computation, all pointing the same way, none of them a direct look. It is a triumph of the scientific imagination, of piecing together an unseen engine from the faint signatures it leaves behind. So let us come home now, back to the question we started with. What keeps Earth's magnetic field alive for billions of years? Now we can answer it fully, and the answer is nothing like the tidy misconception we began by dismantling. The field is not alive because it was created once, long ago, and has simply endured ever since, a permanent relic frozen into the planet. We now know that could never work. A field like ours, left to itself, would decay away in a geological blink, tens of thousands of years, an eye blink against the age of the Earth. It is not a preserved thing. It never could be. The field is alive in the truest and most demanding sense of the word. It is alive because it is being rebuilt continuously at this very moment, and at every moment by an engine that has never been allowed to stop. Deep inside the planet, an ocean of liquid iron is churning because Earth is still hot and still slowly cooling, shedding the heat it was born with. That cooling drives convection. The inner core is still freezing and growing, releasing latent heat and expelling light elements that drive the convection harder. The mantle above still draws that heat away, keeping the engine breathing. Earth's rotation still organizes the churning metal into twisting, coherent columns. And within that organized flow, the magnetic field is perpetually stretched, twisted, folded, and regenerated, rebuilt exactly as fast as electrical resistance tears it down. That is the secret. The field survives not because it is permanent, but because the planet has never once stopped paying the energetic cost of maintaining it. Heat continues to leave the core. The inner core continues to evolve. Conductive liquid continues to circulate. Rotation continues to organize that motion. And so the field continues to be rebuilt, over and over, a flame relit every instant, for 4.5 billion years without a single true pause. It wanders, it weakens and strengthens, it reverses, it does all the restless things a turbulent, self-driven system does. But through all of that, it endures, because the rebuilding never ceases. Earth's magnetic field is alive the way a flame is alive, the way a river is alive, the way a fountain holds its shape while every drop within it is constantly being replaced. It is a process, not a monument. And as long as our planet still holds warmth in its heart, as long as that metal ocean still turns in the dark beneath us, the shield around our world will go on being born, again and again, moment after moment, for as long as the great engine at the center of the Earth keeps running.